OCI, Orange County Inspections, is glad to present the following: the Quality Control and Quality Assurance Professional Seminar, segment number 13. Within this segment, we will cover the welding of reinforcing steel, and the following topics will be reviewed. First is workmanship for the welding of reinforcing steel, and back in 1961, AWS published its first version of the code for reinforcing steel labeled D12.1. But it was short-lived, and the D12 committee disbanded sometime after the publication. Then in 1975, a greatly revised version replaced it with a format pattern after the D1.1 code, and it was labeled the D1.4. And the years of 1979, 92, 98, and 2005 reflected the many industry changes that was taking place within these years that cover the items like the application, welding processes, definitions, base metal stresses, lap joints, the control of distortion, shrinkage, and heat. Next topic is a technique for welding a reinforcing steel, which deals with the materials and welding processes, while also covering items such as carbon equivalent for determining the preheat, the metric conversion system notations, also an introduction with the different methods of joint strength determination that affect items like the filler metal, weld cleaning, and welding of coated base metals. And the last topic is qualification. And ever since the very first edition, it has been used by designers, engineers, and fabricators for the welding of reinforcing steel with items like the WPS and welder qualification, retest procedures, period of effectiveness, how to record, and not to forget the all-important observation of the base metals, equipment, and even the contractors. We start with the first topic, workmanship. The AWS D1.4 code scope shall apply to the following: the welding of reinforcing steel to reinforcing steel, and reinforcing steel to structural steel, plus the D1.4 code shall be used in combination with the building codes and project specifications. A quick tip is, any impact testing requirements of welding reinforcing bars are not included in the D1.4 code. Within this seminar, we have seen with each discipline of the welding industry, there are special items, and with reinforcing steel, there is no difference. Here, we try to teach the basics of understanding and, more importantly, figuring out the formula for carbon equivalent. Every bar is made up of many different chemicals, such as carbon, magnesium, nickel, etc. And only after a destructive chemical test can those numbers be established, which is then placed on the mill certification paperwork. Now, to calculate the rebar carbon equivalent number, we must understand the formula stated by the code. Okay, to start, we see this math formula, and usually that will bring the fear of God to most of us. But let's break it down step by step. First, we need to understand what each call-out in the math equation stands for. So we look at the left side and see a percent symbol, and then the letter C, which stands for carbon, then the addition symbol, and then we come to another percent symbol with the letters of Mn after that, which stands for magnesium, then a slanted line, which stands for division, with the number 6 after that, and then the equal symbol while closing with the letters of Ce, which stands for carbon equivalent. Okay, with math, you must do certain steps before others. And when you see this call out, you must take the magnesium number given from the mill certification for the rebar and divide it by 6. Then you will be able to add the carbon number to it, which will give the total carbon equivalent for the rebar. Does that make sense? If not, let's look at the formula for only the rebar made of ASTM A706 material. And yes, this formula does scare all of us, but let's take it step by step. First, look for equations needing to be done first, like these. Then you can add the numbers up until the formula calls for you to start subtracting, until the total carbon equivalent number is revealed. We look at the welding processes for welding reinforcing steel, and as with plate or sheet steel, there are pre-approved processes that can be used without a qualification test, and those are shielded metal arc welding, gas metal arc welding, flux core arc welding. And if at any time the manufacturer recommendation is not followed or another type of process is needed to be used, that process must be approved by the engineer of record. Next, the effective weld area of a weld assembly will cover the lengths, throats, and sizes. And when dealing with a butt joint that requires a full penetration groove weld, the effective weld area shall be the nominal cross-sectional area of the bar being welded, and when dealing with welds of flare bevel or flare V groove, the effective weld area shall be the effective weld length multiplied by the effective weld size. Plus, if a fillet weld is being used, the effective weld area shall be the effective weld length multiplied by the effective throat. We now move to the joint types used with welding of reinforcing steel. They are direct or indirect butt joints, lap joints, and T-joints. With direct butt joints, they are usually welded with full penetration groove welds, where the indirect butt joints usually are seen with either a single or double flare groove weld. The third joint, which is the lap, can use a double flare V or a single flare bevel groove weld that are stipulated by the different project situations. So please refer to the code for the proper assembly. And lastly is the T-joint that is usually uses a fillet weld and can be found on items such as anchors, base plates, or inserts. The preparation of base metal for welding and reinforcing steel requires the surface to be free of the following: fins, tears, cracks, any defect that would affect the integrity of the material, plus no scale, slag, rust, moisture, grease, or epoxy coating. A quick tip: mill scale that can withstand strong wire brushing is acceptable and may remain. Next, we review the assembly of the joint members, which includes the offset alignment that has tolerances ranging from 1/8 to 1/4 inch depending upon the bar size, plus the clearance between the bars, not only side by side but also end to end. Another quick tip: the welding of bars that cross each other is not allowed except when approved by the engineer of record. Now we move into the weld profiles and review figure 4.1 that states the acceptable and unacceptable tolerances. As we look at the figure, there are 6 different parts that provide tremendous amounts of information, and they are the desirable fillet weld profile, the acceptable fillet weld profile, the tolerances for the fillet weld convexity, the unacceptable fillet weld profile, the acceptable groove weld profile, and the unacceptable groove weld profile. Here we cover a term that many find difficult to explain, and that is the tangent point on a bar. Here we see the figure from the D1.4 code, which states that a weld must start or stop prior to the tangent on the bar. So I ask, if you don't know what the tangent point is, how will you know it's done right? So the tangent point is the location where the bar starts or stops the radius of the bend. We move into the second topic of this segment, which is the technique used for welding reinforcing steel. And one of the major requirements are the filler metals. Because dealing with any connection of the D1.4 code, the base and filler metal strength relationship is probably the one source that will determine whether a weld assembly is in compliance with soundness. And like we have seen earlier in this seminar, to understand and know the proper steps when utilizing Table 5.1, matching filler metal requirements is mandatory. As we look at a part of the Table 5.1, we will alert you to the key parts, which are the following. The grouping, which here is Group 4. Next is the steel specification plus the grade. Once again, we see two columns here with the yield and tensile strengths provided in KSI and megapascals. Moving over to the right of the table, we see the filler metal requirements area, which has you lining up the weld process used that provides the required electrode classification plus its yield and tensile strength. Once again in KSI and megapascals. And would any review of a table be complete without alerting you to slow down and check for any footnotes? Okay, we enter into another critical section of welding reinforcing steel, and that is the preheat and inner pass temperature requirements. With steel plate, usually the preheat is rather low until thick material is used, but with rebar it's totally different, because this is where the carbon equivalent number we saw earlier comes into play. Here is the table 5.2, minimum preheat and inner pass temperatures. And let's review the steps in using the table properly. First is the carbon equivalent range that you will match the number from the bar that is found in the mill certification. Second is the bar size in use. And a quick tip, notice this line item and see the 36 in parentheses? That is the metric number for the number 11 bar size. And this is the actual identification number found on the bar itself in the field. Third is the minimum temperature when using shielded metal arc welding process with low hydrogen electrodes, which provides the temperature in both Fahrenheit and Celsius. And of course, the footnotes. Another key item is the progression of welding, and this covers the fact that arc strikes are not allowed outside the weld area, and especially on the bar itself. Next is the cleaning of the weld with issues like when in progress, the slag should be removed prior to any new weld bead being in place, plus brushing the metal clean, and also this covers any craters when an interruption has taken place. Next is the completed weld cleaning, and this covers again the slag for observation of compliance, plus the removal of any tight adhering splatter, and paint should never be added prior to the weld assembly compliance and recording of such. Another age-old question is about tack welds, and if they are not part of the finished weld and the items of preheat, proper electrode, and defect criteria are not followed as per required by the D1.4 code or engineer approval, tack welds should not be permitted. And we close with the low hydrogen electrode requirements, which are like the D1.1 code, where hermetically sealed containers or ovens of 250 degrees are required, plus review of the D1.4 atmospheric exposure time periods is a must for compliance. As we enter into the last topic of this segment, we'll take a look at the qualification of welding reinforcing steel. The first item is the responsibility that is required for the performed welding, and that would fall onto the contractor. They are responsible for the qualification of both the WPS and welder, plus providing access to these documents, while also providing a safe access to the welding equipment and work area for observation and compliance of the material and workmanship. And if any defects are revealed, the contractor holds the duty to repair for approval. As we just saw, the contractor is responsible for the establishment and approval of the WPS. The WPS for the reinforcing steel follows the same recipe as both the plate and sheet steel requirements, but there are a few special alerts to be aware of. First, the largest bar used within production welding will establish the WPS. Next, the highest carbon equivalent for the bar will establish the WPS. Third is the coating of the bar. That must not be within 2 inches of the weld zone, or it will be needed to be tested as a coated assembly. We have seen this number 4 item before. Any deviations out of the limitations of the essential variable table will require requalification of the WPS. And lastly, the destructive tests required are the full section tension tests that establishes the tensile strength, and the macro etch test that establishes the soundness of the joint. Now is the welder qualification requirements, and this will determine the welder's ability to produce sound welds and not to guide the welder in the how-to for welding. The following are established during qualification: the welding process, material grouping. A quick tip: this does not qualify the welder to weld galvanized material. That will take a different qualification test to establish that. Next, it establishes the bar size, the filler metal, welding position or positions, and the following are the qualification test joints allowed: the direct butt joint, the indirect butt joint, the T-joint, and for the fillet weld, the welder can be tested in one of the following positions: the flat, rotated at a 45-degree angle, the horizontal, fixed, or the horizontal rotated, the overhead fixed, and lastly, the 5F position, which covers multiple welding fixed. The welder certification uses the same destructive tests as the WPS, which are the tension and macro etch, but for the fillet weld, it uses a bend test of greater than 30-degree angle. Now, if the welder does happen to fail one of these qualification tests, there are 2 cases that are followed. One is the immediate retest, which requires an additional 2 test specimens, or the second case is retest after further training, which requires evidence the training did actually happen. Once a welder is qualified, they are considered to be effective indefinitely unless there is a lack of use for more than 6 months or there is a reason for questioning the welder's ability during production welding. And as alluded earlier, these records shall be available by the contractor and examined for compliance at any time. And lastly is the area of compliance using the approved documents, specification, and codes, which is only done by the observation from the quality control and quality assurance professionals. The QC or QA professional that is responsible for the acceptance or rejection of the material or workmanship should have training and experience with metal fabrication, observation and testing in both the shop and field areas, and if required by the authority having jurisdiction, the proper certification. The proper observation sequence items should be as followed. Notification in advance of any production work. Base metal is checked for compliance. Verifying of the approved WPS and welders. Welding equipment are in compliance. Working conditions are safe. Weld assembly size, length, and location conform to drawings and codes. The technique and performance comply with the WPS and code. And lastly, any identifying marks shall be located and recorded on each weld assembly. Another quick tip is die stamping on dynamically loaded members shall be approved by the engineer first. We have come to the end of segment number 13, and let's review the topics we have covered. First was the workmanship of welding reinforcing steel, and we came to understand not only the scope of the D1.4, but the application for items like the base metal, welding processes, safety precautions, and units of measurements from both the U.S. and international systems, while breaking down an important section of the reinforcing steel industry, which is the calculations for the carbon equivalent number. Then we covered the technique of welding reinforcing steel, which revealed the strength relationship of the filler and base metals, and also the how-to for determining the correct combinations provided by Table 5.1, while being alerted on the why the carbon equivalent number is so important for establishing the preheat and interpass temperatures. And lastly, we covered the observation of welding reinforcing steel by mentioning the items that the contractor must accomplish and provide for compliance with the code, like the WPS and welder qualifications. Plus, we covered destructive testing, the joint types used for certification, while pointing out that both the quality control and quality assurance professionals should have both training and actual field experience, plus any proper certification to perform the duties that will enhance the project. The study material for this segment will again bring some very well-written documents to our attention. The first document was written back in 1971 by the U.S. Department of Agriculture, but it brings much eye-opening information about the welding of reinforcing steel used for concrete. Next, we get a secret inside look at the many aspects found in a project specification covering reinforcing steel. The third document is the how-to for testing the reinforcing steel deformed bars and welded wire fabric. And the last document stretches our mind a bit by taking a look at the scientific characteristics of the reinforcing steel strength and ductility. If any questions arise, just email us at orangecountyyinspections@yahoo.com. When completed, move to segment number 14.